Hi everyone. In this session, we are going to discuss about the state change and particularly vaporization and condensation. Okay, first we'll see what is vaporization. What is vaporization? When a liquid changes into gaseous stage by absorbing heat energy, we used to call it as vaporization, or we used to call it with another name, boiling. Okay, when liquid changes into gas at a constant temperature is known as vaporization or boiling. During that time, heat energy is absorbed. Then what is the reverse process? Gas to liquid. The change of state from gaseous stage to liquid stage by cooling or liberating heat energy is known as condensation. Okay, that also happens at the same temperature. We will consider water as an example. Okay, so we have water at 100 degree Celsius. Okay, what happens when it absorbs heat energy? It is converting into 100 degree Celsius steam. Right? Okay. Water, when it comes to boiling point, that is 100 degrees Celsius, it changes into steam at 100 degrees Celsius. Same way, when we cool steam at 100 degrees, the steam has to come to 100 degrees Celsius, then it has to change to water at 100 degrees Celsius. Then, what is boiling point? The temperature at which water or liquid changes into gaseous state is known as boiling point, and condensation point means the temperature at which gaseous stage changes into liquid. So here if we consider water means boiling point is 100 degrees Celsius and even condensation point is also 100 degrees Celsius. Now we'll see what happens to the volume on boiling. So as in the case of ice, like melting, we studied that when the ice melts, the volume is decreasing. It was an exceptional case. As in the case of water, when it changes from liquid state to gaseous state, the volume automatically increases, or we can tell that it is directly proportional. And we'll check what happens with the pressure. Boiling point versus pressure. Okay. What is the atmospheric pressure? The normal atmospheric pressure at 100 degrees Celsius is 760 mm of Hg. This is at 100 degrees Celsius. Okay. So, the normal atmospheric pressure also we used to mention it as 76 centimeter of Hg or 760 mm of Hg, or it can be 0.76 meter of Hg. Okay. You are very familiar that your mom always using pressure cooker, right? What is the reason why she want to use pressure cooker? That means if you are using pressure cooker to cook the food items or vegetables, we can get it easily cooked, right? No? Okay. So the reason is that the boiling point and the pressure is always directly proportional. Boiling point is directly proportional to the pressure. Okay. So once we close the lid of the pressure cooker, we are not allowing the pressure to come out of the cooker, and we are maintaining, or we are closing the pressure. And if we compare the atmospheric pressure and the pressure inside the cooker, it will be 1.75 times the atmospheric pressure. Okay. When we increase the pressure of pressure cooker 1.75 times of the normal atmospheric pressure, we are increasing the boiling point of water from 100 degrees Celsius to 120 degrees Celsius. So that means the water will take that much time, or till it reaches 120 degrees Celsius, the water will be absorbing the heat energy. So by that time, the vegetables or the food items which is kept inside the pressure cooker will cook very fastly. Okay. Now, have you heard about that the people, those who are going for high altitude trekking, they always feel difficult cooking at the high altitude. What is the reason? We know that when we go to high altitude, the pressure is getting reduced. Right now, this 760 mm, the level on sea level, the pressure, atmospheric pressure at the sea level is 76 or 760 mm. Right? Okay. Just consider you are going for Everest. You wanted to go to the tip of the Everest. So when you are going there, obviously you have to carry the food items to cook in between. So by that time, what we are going to feel is that when you are going higher and higher, the atmospheric temperature is getting reduced. We have a proportionality here. Boiling point increases with increase in pressure. When you are going to high altitude, the boiling pressure decreases. So automatically the boiling point will decrease. So that means the boiling point of the water will be less than that of 100 degrees Celsius. So very fastly or before the food items cooked, the water changes into water vapor. So that is the reason when you go to high altitude, comparing with the normal level, we feel difficult to cook the food items. Same way, now we'll see how boiling point affect the presence of impurities. So in the case of melting, we studied that by adding the impurity, the melting point is decreasing. So as in the case of ice, we need that property. Here, when we add the impurities, the boiling point is increasing. So here also in our home, every day we are using the salt, right? No salt. Why we need to add salt to our food items? It gives taste, right? No, actually your mommy is using to add the taste, but unknowingly she is utilizing the scientific reason by increasing the boiling point. By adding the impurity like salt, we are increasing the boiling point. So without much effort, automatically 100 degrees Celsius will be increased to 105 or 110. So by that time, the vegetables will be, the food items will be cooked and it will be tasty too. So by adding the impurity, we can easily increase the boiling point. Now we'll see the heating curve of water. See the heating curve of water, same as like of ice. We need an x-axis and y-axis. X-axis time and y-axis it is temperature. Okay, we'll mark this as a starting point 0, 30 seconds, 60, 180, 120, 180, 240, let it be like that. Then here we'll mark it as 20, 40, 60, 80, 100, 120, 140. This is temperature and this is timing. Okay. So we are taking a water at room temperature. Consider it is at 20 degrees Celsius. So from here, so the starting point is here. If it is at 0 degrees Celsius, we can start from this point. If it is at 20 degrees Celsius, we have to start from here. It is at 20 degrees Celsius. So slowly what happens when we provide heat energy? Slowly the water increases its temperature. Right? No? So slowly happens, it increases the temperature, it increases the temperature. So this shows the increase in temperature and finally it attains 100 degrees Celsius. Okay, it attains 100 degrees Celsius. Till that time it is in the form of water or liquid. Just marking it as A, B. When it reaches 100 degrees Celsius, what happens? Is it any further increase in the temperature? No. When it attains 100 degrees Celsius, it starts boiling. Right? No. So, that portion should be parallel to the timings. There is no change in the temperature. Only time is increasing, but the temperature is still at 100 degrees Celsius. So, it is at 100 degrees Celsius. Just consider this is the point C. Till C, the water is boiling. So, between B and C, we can write it as boiling. So, after reaching this particular position, the entire water changed into steam. So, we are not able to show through the figure. So, after beyond this position, that is steam. We don't have any option to increase the temperature in a practical situation in our school and all, there is no possibility to increase or check the temperature of steam. So that's why we are not showing in the figure. So this is the way we have to draw the heating curve of water starting from a particular temperature till attaining the boiling point, that is 100 degrees Celsius. Only the temperature change is there. Slowly we have to show a slanted line. Once it reaches the temperature 100 degrees Celsius, now the process, the phase, we have to show it as boiling. There won't be any increase in the temperature. So till the entire water changes into steam, we have to show a straight line which is parallel to the time axis or x-axis. After beyond that, it shows the steam. So go through the previous year question papers and find more questions and try to draw the figure and check out whether you are getting or not. Thank you.